All right, so now we're going to work an example of how we determine the phases present for a given scenario and the compositions as well. All right, so here's the question we have. Again, this is on the quiz, so after the instructions, I recommend going over to the quiz, trying it for yourself, and then coming back, and then we'll work through the solutions. So what I want you to do is we're going to work this with the same nickel copper phase diagram, the isomorphous system. And what I want you to do is determine the phase or phases present and the phase or phases composition. So both phases present and composition at two alloys, or sorry, at 2 points. So the first one is 25 weight percent nickel and a temperature of 1250. And then same composition, 25 weight percent nickel, but 1200 degrees Celsius. So those two kind of points determine the phases present and the phases compositions. So do that, and then after you finish the quiz question there, come back and we will work this one together. All right, so we want to determine the phases present and the phases composition at two particular points. And so that would be 25 weight percent on both. So I've got I've replicated it here so that we can kind of work through this on paper. But 25 weight percent would be kind of halfway in between here. So if I draw this line up, that's going to be our 25 weight percent nickel. Okay. And so the first part was 25 weight percent nickel and 1250 Celsius. And then the second part wanted the same composition, but a lower temperature of 1200. Okay, so let's look at the different temperatures now. So this is 1200, this is 1300, and so we initially need 1250, so it's basically right in the middle right here. And so the first point is going to be right there. That is I. We'll call that I. And so the first question asks, and let me just kind of label these regions that we have. This is liquid plus alpha between the lines, and then alpha down here. So at point I, up here, these conditions, we see that we're in the region or phase field of just liquid. So for I, we have 100% liquid. So for 100% liquid or 100% phase region, the composition of the liquid is going to be composition of the alloy, which is 25. So this is going to be 25 weight percent nickel, and that would also mean that we have 75 weight percent copper, just to be clear about that. So that's what we're looking for here. So we determine that we have the phase, only one of them, as liquid, and then our composition is the same as the overall alloy composition, which is 25 weight percent nickel, the remainder, which is 75 weight percent copper. All right, so now let's look at the second one. So this is 1200, and so here, if we move down to 1200, we're at this point right here. So we can tell we're between these two lines, this being the liquidus, this line being the solidus. So we're between the liquidus and the solidus, and so we know that we have two phases. We have liquid plus alpha, or the solid. And because we're in a two-phase field, we know that our compositions of those two phases will be determined by the lever rule. Or sorry, will be determined by the tie line. I'm getting ahead of myself. So that is, the tie line is that horizontal line at that temperature that goes from the solidus, or sorry, the liquidus here to the solidus. So the boundaries of the two-phase field. So if I've redrawn this correctly, then that tells me that this point here, if I go down, is the composition of the liquid at that point, and this point is the composition of the solid, or alpha. So my liquid composition is 20 weight percent nickel. It's important that you specify that it's nickel because we also have copper. And then our alpha composition, so C alpha, is, if this again is drawn correctly, would be 30. And that's again weight percent nickel. So, two phases, liquid and alpha. And then we have just two phases. And then our compositions of those two phases are determined by the tie line, and particularly the tie line intersecting with the liquidus and the solidus to give us those quantities of Cl and C alpha. So that's how we determine what phases are present and what compositions those phases have in a two-phase field.